Hey everyone! So today I'm gonna be working on my Macintosh SE that I converted to a SuperDrive on a previous video. So what I'm gonna be doing today is that I'm gonna be assembling an accelerator card. So this accelerator card is quite interesting because is a remix of a clone of a MicroMac Performer. So Ball created a clone for the MicroMac Performer accelerator card that works also on the Macintosh SE Plus or Classic, if I remember correctly. But this remix was created by Alex Lab, and this is solely for the Macintosh SE. Now, the nice thing about this remix is that, of course, the real estate of the board is way smaller, and also it's a two-layer board instead of four, if I recall correctly. So with a two-layer board is way cheaper to produce, and this card comes as a hybrid, which is the one that I have, where the ICs are like through hole, and the passive components like the capacitors and resistors are surface mounted, or the fully through hole, which everything comes as a through hole. The nice thing about this card, for those of you who don't know, is that I'm gonna be able to convert my Macintosh SE to pretty much an SE30, but without the RAM expansion. Unfortunately, increasing the RAM on a Macintosh SE is pretty much impossible. So I'm gonna get 68030 on this Macintosh SE. The nice thing is that I'm going to assemble all of this with all the kit that I have in here. So before we go to the bench, let's move to the Macintosh SE. Let's do some benchmarks with speedometer, and let's see where we are at. Then after that, let's go to the bench and I will show you how this board is assembled.
All right, so I just finalized doing the initial performance test with speedometer 3.2 or 3 point something, and this is comparing it against the Mac Classic. So it's basically the same machine with expansion RAM. This machine has 4 megas of RAM, and as you can see, it's pretty much the same. The CPU is 0.993, the graphics is 0.98, math is 0.996, so pretty much I got a score of 0.953. So it's basically the base performance that the Macintosh SE is given before we install the accelerator. Okay, so we start with 4 100 microfarads capacitors, which are going to be C1, C2, C3, and C4. So let's solder them. All right, so next I'm gonna go with the second batch of capacitors, which are these ones, and these are C5, C6, C7, and C8. All right, so then I'm gonna mount from R1 to R18 the resistors, and these are 4.7K at 1/4 of a watt. And I just realized that I also missed the C9, which is the clock capacitor, which is necessary if you have an oscillator. So I'm gonna install it. Now what I'm gonna be installing is the FPU and all of the gals, but I have sockets, through-hole sockets, so I'm gonna be installing them accordingly. All right, so I have my Macintosh SE board in here. Now, I don't want to mess this up, so I am going to connect this connector finally, the PDS connector, correctly. So to do that, I just want to make sure that the connector is connected how it should, like this. And then I'm just gonna put 1 or 2 blocks of solder, and then I will just carry on. And as you can see, like, there's no point of contact in the board with the motherboard, so that's good. That's always good. And then I'm just gonna remove this gently. Oops, there you go. All right, so now we solder this. All right, so now that I have these, I'm gonna mount the FPU. So make sure that this side goes here, like so. Now the gals. Next, I'm gonna mount the crystal. So the square corner is the square corner here. Alex also added me some pressure pins, I don't know how to call them. And finally, we need to mount the CPU. Now, it's worth mentioning that you can definitely not use a crystal oscillator if you want. Actually, I'm gonna remove this because I think this is worth mentioning it. And this crystal oscillator is mainly for the FPU, okay? So I have a 25 megahertz crystal oscillator, and this is for running the FPU. Now, if you don't have a crystal oscillator, you just need to jump this, and then the FPU will work with whatever the clock on the bus is. I think it's 16 megahertz, the same as the processor. Also, you can see that you have several types of through holes here, and that's because Alex designed this, so regardless of the crystal oscillator that you get, you can just add it and then it will just work regardless of the size. So 2 things to note. It's not mandatory to use the crystal oscillator, but if you're not going to use it, you have to jump this, and you can use any type of crystal oscillator. You have the different holes for different sizes in here, as you can see. And finally, I just need to add the processor. So to the processor, which I have here, I'm gonna be doing so through a socket. The thing is, I don't have a socket. So what I just did is I 3D printed a PGA socket, and I'm going to use these IC sockets, and I'm gonna cut them and then get 128 pins. I have done this off camera, and now I have like these pins, so I'm just gonna be adding these pins to this socket. And that's it. And just like that, the processor socket that I 3D printed is in. Now, bear in mind that if you're gonna 3D print the socket, it's gonna require some effort because it took me a while to get this in, but I finally managed. And yeah, it's looking pretty well. So let's just put the processor in. Now I can see a small notch in here, so this is where pin 1 goes. There we go. So now we have the board finalized. All right, so we're pretty much done. So while I had my computer disassembled, I just went ahead and exchanged all the capacitors. I know that this is normally not required on Macintosh SEs, but like, I mean, it's a 40-year-old machine, so might as well. So we just attach this to the EDS socket and let's plug it in. Mounting it is pretty straightforward, and I will show you how are the tolerances with the case and the accelerator. So, and it pretty much fits quite well actually, as you can see in here. So if you decide to not put sockets, it would fit even better, but like even with sockets it was quite straightforward. It's not a problem to use this accelerator card.
Okay, so we now have the computer with the accelerator card installed. I'm just gonna turn it on. So far so good. And I noticed that it will take a bit, so I'm gonna speed this up. I want to show you how to install the accelerator on the software side. All right, so right now I don't have the extension installed, so what I'm going to do is open, search for the extension, and we're just gonna drag and drop it here. All right, go and restart the machine. And in theory, we should see this little icon when it starts. There you go. So in theory, we're running with the accelerated board right now. So I'm gonna go ahead and do the benchmarking and I'll be right back. All right, so I have loaded a speedometer, and if we go to hardware information, we can see that we're running with a 68030 with an FPU of 68882. And it also has an MMU, which is great. So we have 4 megs, which is expected. And what I'm going to be doing now is to run the benchmark. All right, so there we have it. And let's compare the tests that I did right now with what we have that I saved the tests. And you can see that pretty much we are like more than triplicating the CPU power, graphics as well, and the math processor, it's also like 8 times as faster, which is amazing. And yeah, pretty much everything is running quite more performant than what initially was. A nice thing to notice though is that the towers, I will imagine that this is the towers of Hanoi. It's 1.24 times faster. A quick sort is done 2.5 times faster than with the 68000 processor. The bubble sort is 4 times faster, and we can see the FPU here in action. I will imagine this is the FPU matrix multiplication, and of course, like on the original hardware, we didn't have an FPU, so there's nothing like to measure against, right? So quite happy with the results, and overall the system feels faster overall. And remember the initial benchmarks that I did? Well, we are getting now 3 times and a bit faster than what we originally have. All right, so there you have it. I have built from scratch almost an accelerator, and it was actually a quite the fun project to tackle, because this accelerator card is pretty easy to assemble. Actually, I was quite surprised how easy it is to assemble this accelerator. Thanks a lot to Alex for providing me with the hardware and mainly for programming the gals that I just don't have the hardware to do that. So many thanks for that, Alex. And yeah, I will just leave some links for in the description for the project. That it's an open source project that you can just like order the parts and make the PCB. So quite happy with the project, quite pleased with my new Macintosh SE++. I will not say that it's an SE30, like, and this is a good question, like, do I think that this is an SE30? No, I don't. Why? Mainly because unfortunately, I am right now capped at 4 megs of RAM, and I cannot put more RAM than that. If there was a way to put more RAM on this Macintosh SE, then by all means, yes. Also, it's not possible to modify yet the ROM on the Macintosh SE, which is something that you can do easily on the SE30. So that's also a caveat on having a Macintosh SE, but performance-wise, it's pretty much the same. I'm actually quite happy with the results, and yeah. If you like this video, please subscribe and like it or not, and I will see you on the next one. Bye.